Hello, and welcome to the first devlog for a game I've been making in Unity for the last 5 months. It's a small strategy game that's set in medieval Japan. My goal is to finish most of the game by the end of 2023. It's probably way too ambitious, but I'm hoping it will motivate me to at least have a playable demo by the end of the year. I chose to make a strategy game because it's my favorite genre. The games that inspire me a lot are Total War, Crusader Kings, and more recently Bad North and Knights of Honor. I think my main issue making a game like this will be scope, since strategy games usually have a lot of interacting systems which need to be created and tested. I'm pretty much a team of one working on this in my free time, so a smaller strategy game is probably still a bigger project than I think it is. I'm hoping that I can mix and match mechanics, for instance combat from Bad North with the provinces from Crusader Kings, especially since I've already created some of them in past prototypes and game jams. To help with the scope, I also plan to target mobile devices as the primary platform, since the limited screen space and input methods should help me keep the game from getting too large. The location of the game also takes into account the limited scope of the game. By setting it during the Warring States period of Japan, when warlords fought against each other for control of the country, I can pretty much use the same assets across all the factions, while also still having multiple factions competing with each other. The first thing I had to do for the game was figure out what the map would look like. The process for making the map is pretty simple, but very tedious and time consuming, so I spent a lot of time researching various maps of Japanese provinces. In the end, this is what the map looks like. This was then split into two images, one with no outline provinces, and one with the provinces arranged into a sprite sheet. Then I brought these into Unity, added each province sprite to a tile prefab, and finally positioned the pieces to recreate the original map. The map is tile-based, like Crusader Kings, which will make systems like pathfinding, selection, saving, and loading a lot easier in the future. Oh, and I also already made a game that has tiles, so I can reuse knowledge from that. While making the tiles, I came across this really nice map from Victoria 2, and I wanted to use similar colors for my map. I noticed that a lot of the colors on this map had an RGB color value between 100 and 200, so all I had to do was loop through the tiles and set the color of each one to a random value between 100 and 200. I did this using an editor script, which can help automate development a lot. I'll likely go in and hand tweak these in the future, but for now the map was feeling done, so I moved on to the touch controls. I've never programmed touch controls, and I've never used Unity's new input system, so I decided to do both. I followed this tutorial from CodeMonkey and was able to get simple touch controls working. The touch controls are very important because this is the main way you'll be experiencing the game. If the controls are not smooth, playing the game will feel like walking in uncomfortable shoes, and you can do it if you have to, but you'll want to take them off as soon as you can and play a different game. So I first did market research by swiping around different apps to get a sense for what good touch controls felt like. The key controls I needed to implement were selecting things with a touch, dragging the map with your finger, flicking the map with a swipe, stopping movement with a touch, and zoom using 2 fingers. It was easy enough to implement touch controls, but making them feel seamless took a lot of tweaking. Flicking the map with a swipe was especially hard because it needs to feel predictable. It's all about how you reduce the initial swipe over time. Too much speed reduction and it feels very sluggish and unresponsive, but too little speed reduction and there's no control over the map. The solution that seemed to work the best for me was to add a rigid body and allow drag from physics to naturally reduce the speed over time. Another thing that complicated touch controls was the refresh rate of my phone was way faster than my computer, making it so that a single tap when testing on my computer would be multiple taps on my phone. This would also cause the map to get flicked in the opposite direction, since lifting my finger off the screen would get picked up as a reverse swipe. To stop the multi-tapping, I added a 0.1 seconds timer after every touch. To fix the reverse swiping, I made it so that the swipe direction was calculated from the last 3 recorded touches instead of the last 2 recorded touches. Now that you could interact with the map, I needed to add UI so you could actually do things on the map. You can see here how the UI has evolved over time. I like the UI so far, but I'm expecting it will change as I add more systems to the game. Since I'm planning for the game to be on a phone, which has limited screen space, the UI needs to be narrowed down to the most critical actions and information. The play and pause controls are placed near where your thumbs are for quick access. At the top you can find faction resource information, which shows gold, number of territories, and number of armies a faction has. Around this there are 3 tab sections. The first tab shows faction information. The next tab is the building tab, where you can see what's built and build more buildings. The third tab is the army tab, where you can see what army is garrisoned and build more units if you want. All the basic game interactions are done, and I feel like I'm making really good progress. The next thing to start is adding units to the In August, my computer died, and I was not using source control or the cloud. Since my computer was around 10 years old and not turning on at all, I had to buy a new computer. In September, I got a new computer. However, I still had the issue of getting data off my old hard drive. It was not working, and I did not want to mess around with it too much. I was worried I would accidentally erase everything. Then, I got super lucky and figured out that my graphics card was burned out. My computer would actually turn on when the graphics card was not installed, but I could not see anything on the screen. I ordered a replacement and was able to fix my old computer to transfer files to the new computer. Lesson learned: to always use source control and upload your projects to the cloud. Okay, Where were we? Next, I added armies to the game. I wanted combat between armies to happen on the map layer, but I also did not want it to be so messy that you could not see what was going on. So I went with little squads of 6 units for the armies that fight on contact with other armies, or when they're moving to a tile that has an enemy army on it. With all these armies on the screen, I really need to limit the amount of clickable stuff in the game, or else you would always accidentally click the wrong thing. So I decided that armies would not be directly selectable. You can only select tiles, and from there, you can tell an army what to do. This means when an army is moving, it is not commandable until it is garrisoned again on another tile. Pathfinding is also kept pretty simple, since this is also tile-based. I use a basic flood fill search across all the tiles and use tile distances to determine the final path. For unit combat, hit chance is calculated by comparing one unit's level to the other unit's level, and then adding a combat bonus based on unit type. The bonus is a basic rock, paper, scissors system. Cavalry have a bonus against archers, who have a bonus against infantry, who have a bonus against cavalry. I think I will add a couple more unit types in the future, like spearmen for example, but it really starts to get harder to balance everything with more unit types in the game. For unit art, I'm using a cool asset pack by Seek on itch.io called Mini Folks Humans, which I've linked in the description. I plan to swap these out eventually with more Japanese specific sprites, but for now they work great. For coloring the sprites, I can just I created a custom shader to color the units dynamically from the faction color. The shader takes in 3 different blue colors on the sprite and then replaces them with the same shade of the faction color. Now that all the units can fight each other, it's time to give the game some brains. The AI has always been one of the places where my larger strategy game prototypes die. As a human, we can see something like this and determine an overall plan pretty quickly. We can see these territories are under threat, this territory is open to attack, we could reinforce the border with this army, but it's a weak army, so we also need to strengthen it. We should also strengthen these armies. We can use this strong army to eliminate this threat, and finally add another army here to defend the border. It's harder to replicate this process with an AI, so to make this easier, we create AI that is driven by the tiles instead of the faction. Each tile is an independent AI that decides what action to do based on who owns it, how strong it is, and what the surrounding tiles are doing. For the last example, the AI might do something like this, where it only attacks where it's strong and increases strength everywhere else it's weak. My initial solution was to have 3 tile parameters: danger, value, and strength, with 2 different states, low and high. I mapped out this matrix to match what I thought a human would most likely do for each combination of parameters. And this works, but there's a big problem because it's not a scalable solution. Any increase in parameters causes the number of conditional states to increase exponentially. For example, if I wanted to add a medium value between low and high, the number of states would go from 8 different cases to 27 different cases. This would get very time consuming very quickly and would lead to a lot of bugs almost immediately. To fix this, I ended up reversing the problem. Instead of looking at all parameter combinations and their resulting actions, we look at all actions and calculate their potential based on parameter equations. The way you can visualize this is with a pachinko machine. The bins at the bottom are actions the AI could take. Each action has a weight associated to it based on a calculation of tile parameters, which is signified by the width of the bins. Then when you drop the ball, it bounces around until it randomly lands in one of the bins, which for us is just a random number we generate and then match to an action the AI will take. With this, I can add any number of actions for the AI, and I also have the flexibility to change tile parameters and tweak equations without too many issues. Overall, there are still improvements that need to be made in the AI, but for now, it's in a good spot. Buildings don't do anything yet except give you more gold. When one is built, it spawns randomly within the bounds of a tiles collider. Sometimes they land in weird locations, but the building sprite is just visual, so I don't feel like it's too important to fix. In the future, I want buildings to have different unique functions like unlocking different units or improving a tile's attack or defense. And that's it for the first devlog catching up to 2023. I'm really happy with the current progress so far. I've tried iterations of longer term strategy games in the past, and this is the first time I feel like I could actually finish it. If you have any feedback or suggestions, let me know in the comments. Like and subscribe for future videos, and if you want quicker updates, you can follow me on Twitter where I post what I'm working on.